Okay, what's happening, everyone? Today's lesson, which hopefully, fingers crossed, will be the very last one that we do remotely like this via video before we come back into school next week. This is on something called position vectors. Position vectors basically are relative to the origin, so you can basically think of them as a coordinate. So, for example, if I have a coordinate 2, 3, if a vector goes between 0 and 2, 3, then that is just the vector 2i plus 3j. Okay, so if the point A is there, then OA, the vector OA, is that one, 2i plus 3j. Okay, and basically we're just going to be using these today, still looking at things like modulus and magnitude, size of them, and all your other things that we've already done with vectors. It is really easy. If you want to, you can write these things, by the way. We're working through this. If you prefer to work using column vectors, that's fine. I'm going to keep everything today in terms of I and j, I think. Okay, so let's just have a quick look at this, because this gets confusing with people sometimes. Okay, so just highlight that, because that is really important. Let's say we have these two coordinates A and B, there and there. Okay, so my position vector for A would be OA, which is between there and there. My position vector for B would be OB, which is between there and there. If I want the vector to get from A to B, remember that what's going to have to happen is I'm going to have to go back to the origin first, which means I'm going to have to do the negative version of OA and then the positive version of B. Negative version of A, positive version of B, and that's what's going on there. So whenever you get if it asks for the vector AB, you do B minus A. You basically start there and take away that one, okay? Because students always seem to want to do A take away B. It's not, it's B take away A. Because if you're starting at A, it means you have to reverse the position vector of A to get back to the origin and then go the positive way down B, okay? So that's really important. The rest of this is dead easy again, okay? So let's have a look at this one. Example 14, the points A and B in the diagram have coordinates 3, 4 and 11, 2 respectively. Find the position vector of A. Dead easy. 3, 4, that just means that's 3i plus 4j. To get from there to there, that's 3 across, 3i, 4 up, 4j. So think about what the next one's going to be. Do you want to write down your answer before I write mine down, as I kind of maintain your turn thing? Part B, the position vector of B, and B, the coordinate, is the coordinate 11, 2. So that's just 11i plus 2j. Dead easy. Okay. Right, part C, the position vector, the vector AB. So to get from A to B, if I want to do that, I'm going to have to reverse A. So I'm going to do minus OA plus OB. So that will be minus 3i minus 4j plus 11i plus 2j minus 3 and 11 are going to give me 8i, and that's going to give me minus 2j. Okay, so that's it. So you could have written that the other way, by the way. I could have done B minus A if I wanted to, so I could have just done this one and take away this one. Completely up to you, you'll get the same answer. But basically, whenever you are doing the vector AB, it is the A part of it that needs to be negative. Okay, so that's that one done. Let's have a little look at the next one. Example 15. So this time we're given OA and we're given AB. So, and we're being asked to figure out the position vector of B. So what we have to do here is set up this equation again. Okay, so remember, to get from A to B, we would do B. So we do the position vector of B minus the position vector of A. Okay, just a quick note on that. I basically did that the other way around there. Okay, so I could have written that if I wanted to, the way that I've just done it there. Could have done OB minus OA. Okay, B minus A. It's always B minus A when you get from A to B. You always do it in reverse. So if I've got these, I'm now just going to fill in what I know. I know AB is 3i plus 4j. OB is what I'm figuring out, so I'm going to leave that like that, and I'm going to minus OA. I put it in brackets, and that's 5i minus 2j. Okay, so all I need to do is get OB on its own. So these things need to go over to the other side. So the first thing I'm going to do is just get rid of the bracket. That'll be minus 5i plus 2j, remember, because that minus, I'll turn that minus positive. Then I just bring everything over to the side. So that minus 5i, when it goes over there, will add on to the 3i to give us 8i, and that 2j comes over there, will take away from the 4j to give me plus 2j. So that's the position vector OB. Okay. And then part B, it just wants the mod of this, the magnitude of it. So again, remember, all we do with that is just use Pythagoras, a positive Pythagoras, using them two numbers. So we're going to do root 8 squared plus 2 squared. When I'm saying positive Pythagoras there, remember, all I mean is if that had been 8i minus 2j, just use plus 2j still. Okay, plus 2 squared, sorry. That gives me root 68. And then it wants it in simplified surd form. So biggest square number that goes into 68 is 4. So this simplifies to 2 root 17. And that's it, basically. Okay. So what I'd like you to do now, please, is have a go over the page. I'd like you to do the odd numbers in exercise 11D, please. So 1, 3, 5, and 7. That's it. Okay. Which sets us up quite nicely, because obviously the tricky part then is doing actual problem solving with this. So effectively what we've done here over the last 4 lessons is set you up with the kind of skills that we will need to do things like this, okay, which are the more tricky style questions. So have a go at the odd numbers from that, and then upload your solutions to Teams, please. Next one.